Greetings, universe! Hello. Hey, Maraja. Thank you for coming. Thank you for joining. Yay! How are you? Hope everything is okay. Today, we're going to talk about the data life cycle. It's going to be a bit more educational than usual. Yes. Okay. So, what we're going to do today is talk about the source, the oil, the gas that is able to create this AI world and power it. Yes. Maraja says that he's looking for ideas to introduce to his class. Oh, okay. So maybe I will be able to give you some inspiration today. Yes. Okay. So I think it is safe to start. Right, so social media platforms. So we have to admit Twitter is kind of not in the best place, calling itself X. Maybe because it's going to die soon. I don't know. We also have TikTok, which is on the rise, Instagram, which is pretty strong, and Facebook for like grandparents, those that are kind of not very young in Earth terms, that is. So we have all those kind of social platforms. They are currently free to use. Twitter has their own ideas of making that like there are rumors which are not very rumors, just Elon Musk being Elon Musk. He's saying that Twitter will probably go completely as a paid service. But the other ones are free to use. And the reason they are free to use are because their source of revenue is mostly because of ads, because of advertisements that they show to the users. So, yeah. Basically, what these companies want is for you to be as engaged as possible in their social media platforms, so you can view as many ads as possible. What kind of data do they collect about you? Roger says Google didn't DRM the internet yet. Yes, maybe it's going to be pretty soon. Maybe. So the question here is about these social media companies. What kind of data do they collect to keep us in the app as long as possible? Keep us scrolling. So they're kind of looking into all sorts of data. Allegedly. I don't work in any of these companies, so I don't really know. So this is all allegedly. So generally they are collecting the posts that you like, so they can know what to show you in the future. they check out your age. So usually, like young adults, they're going to college, so you will be shown ads for college. If you're an adult, maybe you'll be shown advertisement about insurance and stuff. Yeah, so this is also a reason why looking into your age is also very useful and valuable. What else? Allegedly, maybe they are listening to everything we say. So they're collecting microphone data too. Maybe. That's how maybe they listen to our conversations. And then they know what kind of ads to show us. Could be. They're also trying to collect interests of you. Like, assuming you are looking for a certain topic, for example, photos of space. And when the social media platform is showing you photos of space, it is seen that you are spending more time on them and that you like them. So maybe the social media platform can categorize you as a space lover. So that's how they know to show you more photos of space. Marager says they want to collect routines, interests, hobbies, group activities. Oh yeah, for sure. Yes. I mean, we don't really know because the code is a secret and we don't work there, but we can assume. We can make assumptions. Yeah, also, assuming the platform has some type of a group system, for example, Twitter has groups. They're all based on a certain interest. So, yeah, Twitter will prefer to collect data about what kind of groups you're active on. And therefore, maybe to find more individuals with the same interests as you. And if you react positively to the advertisement that they show you, maybe they can show the same ones to the other members of that group. Yep. So, generally, lots of types of data that is being collected. Okay, so we can kind of categorize these types of data into two categories. One of them is raw data. For example, if you do a like, if you are friends with someone, if you commented somewhere, or even your location somewhere in the space. All of these are considered as raw data because they don't have any kind of logic applied. They don't have any kind of code applied on them or transformation applied on them. Unlike, for example, a trend. We can take a look at a trend. This is something that requires a logic. For example, to identify a trend, we need to make sure that it's being searched a lot, or after a certain amount of, like a certain threshold, or in terms of maybe percentages of out of everything that all the people search, everything that people search, out of all of that, what is the percentage of a certain keyword? That one is being trendy. But we applied a logic here to find the percentage. Or maybe it's not just by search. Maybe it's also by content produced about this topic. For example, what if people started to like a certain type of cake? So they are, let's say that a space cake is suddenly very trendy. Like a cake with like stars and everything, and it looks spacey. It looks like a galaxy. Let's say galaxy cakes are a new trend. Yes, that would be great. So suddenly the platform sees that there are many photos and many videos about this topic. So they can consider, after a certain amount of content or posts that have a certain specific tag, then it's a trend. Weeding it, no, grass is not great. Grass does not compete with cake. Grass is, I don't think it's a human type of food. I think you're missing something. Yep. Another transformation could be interests. Like what you are interested in. Because it has to be based on some logic, like what kind of posts you're creating, what are you talking about on the platform, what kind of posts you're liking or spending extra time on, what kind of groups you're joining. All of these will be taken into consideration to define your interests. So because we apply some kind of logic, it means it's not raw data. It means it has been transformed. Okay, now we can finally introduce you guys to the data lifecycle. It starts from planning what kind of data we want to acquire. And then we're actually catching the data. And we need to manage it to make it more useful, to make it more clean. So it will be possible to analyze it in an easy way. Then, if we no longer use the data frequently, we archive it, and by the end of the cycle, we destroy the data. Yep, let's start with the planning. Generally, we're here to ask a question. I mean, there are several approaches to this, right? Either we first define a question and get the data based on that, or we can collect data and only then ask questions on the data. These are like the two approaches we can do. And first we will talk about defining a question. That would be the more, I would say, it would be the better practice to first define a question, to understand what we need, and then to collect data based on that. Roger says, collected from individuals but stripping the individuality from them to look at more specific data. I mean, yeah, today you wouldn't want to have someone specific to be your data point. You would want to collect data about a group of people to understand the group as a whole, not as an individual. The individual itself, unfortunately, is not very interesting. For better and for worse, because it can help with privacy, because this way, if you're only part of a group, it's really hard to distinguish who you are, which is actually a better idea for terms of privacy. So your privacy theoretically is being kept, sort of. I mean, allegedly. So we kind of need to think, what is our research question? If we're going back to the social media platforms example, then it's like the question is, what do these companies ask? What is the research question? That's kind of what we need to know. And if we will know the research question, then we will know what kind of data to get. So, yeah. What is our research question and what kind of data do we need to answer this question? Also, we need to define at this step who will get this data and how, and who is responsible for the data. Yeah. So, what was the question the social media company asked during planning when they planned what kind of data to get? No, it's not how to get more money. Ooh, hello, Tank. Thank you for joining. So, we're talking about social media platforms. And they really want us to stay in their app for as long as possible. So, the question they're asking themselves is actually how to get the best engagement. If you are engaged, you will stay for longer in the app, and therefore you will see much more ads. And these ads views are going to get them the revenue. So their question is how to raise engagement, how to keep you engaged. Okay, let's take for example the IMDb database. It has all sorts of movies and TV shows and data about actors. So yeah, they have a lot of data, a lot of data. They have 10 million titles, 11 million personalities, which is also directors and producers, not just actors, and 83 million registered users. That's a lot of data. Yes. So, what kind of questions can we ask based on this data that we have here? If you remember, I said there are two ways to approach this kind of planning phase. Either you first ask the question and then you get the data, or like we see here, we first have the data and then ask questions based on it. So we can ask ourselves, what is the distribution of the actor's age in a movie, in a certain movie? We can also try to see what kind of locations are most used for certain types of movies. Like, are there reoccurring locations for comedy movies? If we were talking about TV shows, then we have the example of a group of friends that usually go to a certain restaurant or to a certain bar. And this is like a reoccurring thing in comedy series. So what about action and what about drama? This is also the kind of question we can ask. We can also try to predict a the rating or how much money a movie will make based on its criteria. Like we have data about the actors that are starring in the movie. We have information about their history. So maybe based on that, based on the people that work on the movie, we can predict the rating before it came out. We can also try to predict rating of specific user for movies or shows. So it means that we have the user's ratings for previous shows, like he have a history of ratings of, like for example, a user watched multiple movies and the user rated them in certain ways. So based on that, maybe we can recommend another movie for them. Okay, so how do we get data? We're done with the planning phase. We thought about this enough. And now we're actually on trying to capture the data, trying to get the data. So there are multiple ways to do this. One of them is creating a tracker. It doesn't mean necessarily that what is being tracked is your microphone. And it doesn't mean that you're being listened to. But there are also other ways of tracking, like where your mouse is on the screen or where your eyes are looking on the screen. That can totally happen. Marager says we have a history of Bethesda games and we can easily conclude how new releases will function. Ooh, I feel some shade in this comment. Ooh. Maybe. Yeah, that can do. But it's really hard to predict how a certain game will perform based on their history. Sometimes there are surprises, good or bad. So a tracker can generally take a look at what you're clicking right now. Like for example, if you are shopping for new shoes, so the tracker will send an event to the server for every click that you do, every scroll that you do on the page to see what you prefer. That can totally be a thing. Derek says, honestly, there are too many variables to accurately predict that. Past performance does not necessarily indicate future performance. Yeah, so there are many features that we will need to consider in order to make a good prediction. Many features. We are talking thousands of features. Maybe even more. Okay, what other kind of ways do we have to capture some data? We have crawlers and scrappers. When a crawler is looking into like multiple websites, for example, we can take Wikipedia, which is going through a certain page, and then the crawler is taking all of the links in that page, and then in like a recursion kind of thing, it takes all of Wikipedia stuff. Yes. Think. Yes. Or a scrapper. A scrapper will take a look at a certain page. For example, let's say there's a website that shows the weather for a specific location, and we only care about that. So we can take the HTML page and parse it, and that would be some kind of a scrapper kind of thing. Another way to capture data is with APIs. For example, if we're actually going to have an API that will show the weather for everything, and then we don't need to look into weird HTML pages. We can just use the interface that is built for us. That's usually a much more convenient way to do things. But on the other hand, you're kind of relying on the company that provides the API. I mean, in all cases we are depending on these companies, but this kind of convenience is not always free. Another way to capture data is to use pre-made datasets. There are 2 websites here, actually 3 websites here, that have really nice datasets that you can use for your projects. And depending on the kind of question you have, maybe you can find data that someone has already worked on and use that one instead of creating your own dataset. That can totally happen. So these websites are totally worth checking out. And last but not least, wait. I'm gonna go back. Tank says, as is the case with Twitter, where they put their API behind a large paywall. Yeah, exactly. At some point, Twitter was like, the Twitter API was free, and now it is not. Exactly. Ooh, hello to Kada. Have I pronounced your name correctly? Thank you for joining. We're talking about the data lifecycle at the moment. So we have already talked about the planning stage, and now we're talking about how to capture data. And the last but not least way to get data is to go the do-it-yourself route. So the tracker and the crawler and the scrapper are already examples that we have already discussed in this case. They're all DIY. But also you can conduct surveys or take photos of the world by yourself and categorize the photos by yourself. Or you can just look at the world and take some notes about it. You will probably not going to be able to reach big data scales. So the analysis you'll be able to do is going to be kind of limited. But maybe there's a way for you to automate how you take those photos. For example, if you are going to take a look, with permissions of course, for already existing cameras around the world, there is a way to do that. Ooh, hello, Uma. Thank you for joining. We're talking about data today. So if you have any questions, let me know. Okay. So now that we have our data, it's not necessarily clean enough to use. It's not necessarily good enough to already start analyzing. So we need to combine the data sources that we have, the datasets that we have, into something more unified. So we have an example here for a CSV file, which is sort of like an Excel file, where the first row indicates the header of the table, and we have a lot of values. So, for example, in this case, the name is John and Judy, and the company is ABC Company, and the address is 123 whatever. And for the second row, the name is Merle and Betty, and the company is unclear, and the address is 321 Broadway something, whatever. So this is the kind of data set that we have here. Marager says that CSV files are the devil. I disagree. There are far more scary file formats, like XML. XML is the worst. So, another source of data we have is XML. And we have a student list where we have the first name and the scores that the student got for 3 courses. So we have Greg and we have Wirt, and these are Greg's grades and these are Rit's grades. Tang says they can be painful, but the bigger the datasets go, the more frequently you are using it CSV as an intermediately on the ETL process, at least if you are going into structured. Yep. Whew, XML versus JSON. Oh boy. Okay, so maybe I will start a poll. Let's start a poll to see what do people prefer. Okay, we'll call it worst data files to work with. And we have CSV, although I like them. We will have XMLs. And we will have JSON. Okay, I have started a poll. Let's see what people say. It's on YouTube, the poll. Okay, so far it's 50-50 for CSV and XML. Oh no! Whoa, someone says that JSON is also... Okay. We will keep the poll running for now, and we will go back to the presentation. So we want to have the address of the students so we can send them their grades by mail. We will need to find a way to combine the XML with the CSV by name. So a student has to appear both here and here so we can find their address. This kind of logic is called transform, and this is one of the more basic ones that you could do, but it's just an example. Whew. Oh boy. Oof. This is the hard truth. Let's take a moment. Yeah. So the fun part is the analyzing part. But in reality, we spend much more time on cleaning the data and preparing the data and make it all nice and lovely to use. Just had to put it here because it's important to recognize the hard truth. Yes. Okay. Let's try to do something together. So we have here the house pricing for Iowa for 2010, for the year 2010. Some of the data here is kind of weird and incorrect. We need to find out what are the rows that or the cells that are not very correct. Can you figure it out? Try to look for numbers that maybe don't make much sense, or for some errors of some kind. It takes a moment to look into the data first to see what's actually wrong. So it can take a moment. Quality over 10. Yes, that's a good point. We see here that the score is kind of going between 4 to 9, and suddenly we have 18. Yep, that must be a mistake. True. Another example I see here is the year built for the house. 1860? Wow, this house is very old. Maybe it's true, but honestly, kind of unlikely. Especially when you see the rest of the years for everything else. What else can be looking weird here? Roger says the discrepancy between modify and built. Well, maybe. Do you have a certain specific cell that looks weird to you? Okay, so for example, we have all of these null values. I mean, they're probably not mistakes, but if these are nulls, then the data is not very useful here. An additional example is for the lot area, which is a very low number here. That kind of doesn't make sense. Could it be a house that is so small? It's probably a mistake. So here are the answers. Okay, so this one, it seems that for the neighborhood column, everything is all crammed out without any spaces. So suddenly we have one here with a space, while we have here without a space. So that could be a mistake. Yes, Marjorie, you're correct. Also we have this kind of number here. We're talking about 2010, and this is in the future technically. So that's probably also a mistake. Yeah, so when we manage the data, we're also taking care of making it clean. The things that we can do to clean the data. If most of the values for a certain column are mostly empty, mostly nulls, then we can remove the column probably, most likely. Also, redundant features can be aggregated together, which means if we have a country, a state, city, and a zip code, we can just put it all together in a location. And then we have just one feature instead of 4. Or for example, if we have the height and width of a specific house, we can just call it an area. On the other hand, we can also split features to improve resolution, which if we have a website, then we can take it into subdomains and domains and top-level domain, like for example here. Do you have any additional examples for that, maybe? Sometimes we will need this kind of resolution, so maybe we will prefer to have the city separately. That can also happen. Feature scaling, normalization, outliers. They're usually found when you're exploring the data, when you're trying to already analyze it, so you can kind of go back and forth in these two steps. Analyze and manage. Yes, we need to clean all the data. Yes. Okay, let's say hi to the probably most known data set in the world of data. It's like the hello world, the greetings universe of the world of data. So, in this data set that you can check out over here, you have 3 types of flowers. All of them are irises. These are the kinds that you see here. And there are 4 features for them. Roger says, when analysis incidents related to network activity, I teach my students to filter out these PCAP files to get a better understanding on what might have happened during the recording. Yeah, that's a good approach. Yeah. So the attributes that we have are sepal width and length and petal width and length. And you can see here which is which. This is the sepal and this is a petal. That's how it works. If we're going to look into the data, we will see that it will be possible to categorize into multiple bins, which means groups. Basically, a bin is a group. And histogram is used for checking out the values distribution. For example, here we see that the petal width count is mostly over here. So most of the petals are pretty short because we see that most of the examples are over here. This is like a very convenient way to see how our data is being distributed. A box plot can be used to check out the percentiles of the data. So this is usually what we have here are outliers, which means it's what most of the data is not. And yay. A scatter plot is kind of confusing one, I would say. It takes time to get used to it. But the moment you kind of understand what's going on, then you see how useful it is. So we said that we have all of these features here and all of these features here. We can clearly see that each type of flower is being separated almost completely. If we will go for this visualization, we will see that the setosa is like right in the corner, which means it's clearly a different kind of flower. If we will go for this visualization of the scatter plot, we will see 3 groups. Even if their colors and their shapes were exactly the same, we would could tell just by looking at the visualization that there are 3 types of groups here. So this is a very useful one. Importance of the visualization, just so I can show you why is it so special and nice. Okay, so what do we have here? Here we have a latitude, a longitude, and a temperature. It's really hard to tell what's going on, right? It's not very clear. But if we will visualize the data, we can totally understand that the closer you are to the middle, the warmer it gets. So this is the same data, but visualized. And now it's much easier to understand what's going on. Okay. Are there any questions about this so far? If no, let's continue. Let's talk about archiving data and destroying data, which are our very last steps. So, archiving data, we will usually do it for data that we don't really use much. Usually when the data is new, like for example from the last week or from the last few days or even the last month, then we access it on daily basis in order to get our KPIs, which show either the monthly active users on the platform or daily active users on the platform. So we will access this type of data rather frequently. But data that we acquired about a year ago might be useful but not very often. So we will prefer to archive this type of data. Why? Because then when we make our calculations, we need to go over less data to do that. So our computation will be faster. Yeah. Another thing that we need to do is maybe to destroy the data if it's not relevant to us anymore. And this way we can save storage and money, because if we're using cloud storage, then it costs quite a bit. So if we will delete data that we no longer need, which is no longer relevant to us, then it means that we can save some money. So yeah, this is the data life cycle. We're starting from planning, then we're capturing the data, we manage it, we transform it, and then we finally analyze it, and eventually we archive and destroy the irrelevant data. Yeah, this is pretty much it. Okay, I hope this was useful for you guys. If there are any questions, you can check out the Discord. I will spread the links. Just a second there. This is going to be the links for the Discord where you can ask questions. Okay, it doesn't work. Oh, it worked. Wait. Strangely enough, it doesn't show the socials. Doesn't work. That's strange. I will check out the Discord link in case you guys would want to join. Thank you, Maraja. I'm happy that it was useful for you. That's great. Maraja says, I now have a way of explaining data collection to my students. Almost direct per... Yeah. Okay, that's nice. So, if you have any further questions, feel free to join the Discord. If you want additional kind of stuff like that happening, then you can also request them. Yeah. So see you there and have a lovely rest of your day.